This is that tool post grinder that I made. You can see it up close here. Basically, I took an aluminum block, cut a dovetail in it for the quick change tool post, so it can slide on there. This knob was put on here to actuate the switch on the cutoff tool that's inside here, and you can just turn this and it depresses that button so you can control the speed of the wheel. And then I use some set screws, 2 here and 2 there, to lock it into place inside the block. So this can go this way on the tool post. It can flip over 180 degrees on the tool post the other way, depending on what kind of grinding operation I want to do. These work good. You can only take off a little bit of time with it, but you know, it's just a tool to use once in a great while. So let me show you how this will flip over. Okay, I loosened up the clamp on the tool post, and you can just take this whole unit and flip it over on the dovetail. It's kind of hard to do holding the camera, but it'll go either way, and then it can adjust up and down, below and above, or at center. And when you get where you want it, you clamp it down with the tool post holder. You can change the angle on it and work it in any way you want. If I had to build it over again, I would pick a little bit bigger grinding wheel. Of course, I can always buy another larger one. This is a 4-inch wheel I have on here now. It would probably be good to have a 4-inch and maybe a 5 or a 6-inch one also, so you can get in different places. And to do something like a crankshaft journal, where you set the crank up like in a 4-jaw chuck, you're going to need a fairly large diameter wheel. I haven't even calculated that, but that's got to be at least a 6-inch wheel, maybe even larger, to do that. And this tool post grinder is simply just held in with some set screws. There's 2 on this side, and there was 2 on the top next to the speed control. And it's just a round bore inside this block. And you can see the other 2 set screws. So they just cinch it down. Not too tight, otherwise you won't get things to turn inside there. It's just tight enough to hold it still. If you make one of these, get a decent quality cutoff grinder. Make sure there isn't much play in the bearing. If you can feel it move at the store, if you can feel the arbor chuck around on it, don't use it. This wasn't a very expensive one. I think it was like a $20 or $30 one, but the bearings are nice and tight on it, so it's not going to have any wobble or run out. And the type of wheel I used is a CBN type material, and that's usually preferred for doing steels, metals. And I just simply made this arbor that holds it out of aluminum because it was easy to make that way. You can make that out of steel and get something that's going to hold up a little bit better. The flywheel's been put on that crankshaft. I just turned the taper on. The idea is to spin this and see how true it runs. I like to do that just to make sure that the taper got done right. So fire this up. You see it's running pretty true. There's normally a little bit of wobble in these flywheels, but it's not really moving side to side. It's tiny bit on around, but that's how the casting is. But that looks pretty good. Should work just fine on one of these Kart motors. Normally wind up to about 8,000 RPM. That should be just fine for it. This is the tool post grinder I just finished making. What I've done here is taken an air pneumatic cut-off tool and inserted it in an aluminum housing and made up an arbor for a 1 1/4 inch ID quality grinding wheel. And I added this bolt, just a bolt with a spring and a simple turn knob shoved onto the head of the bolt for a speed control. And this, I took off the lever, safety lever on-off switch that's normally on this, and just make this bolt so it goes down and depresses the plunger. You can see it's going. That's how it turns on. I made this to go on the tool post holder, so I can loosen this up and adjust the height up and down. Or I can take the whole thing off. And flip it over. Go on either way. Speed control's on the bottom, but you can still reach it. So to go on either way, this way or the other way. And the height's adjustable either way. So I was able to get this wheel and the arbor to turn within 1/1000th of an inch PIR, which isn't bad for an inexpensive tool post grinder. Seems to do a pretty good job. Surface finish is pretty nice. So I made it to do some hardened crankshaft journals and redressing tapers on crankshafts for vintage Kart engines, and doing just general crankshaft repair. But it'll also be good for turning wrist pins and hardened components that you can't normally turn on a lathe. But you just have to be patient using it. It doesn't have a lot of power, so you have to keep the RPMs up on the grinding wheel, which means that you're only going to take 1/1000th or 2/1000ths of an inch off at a time on each pass with it. So it's just for doing light jobs where you have a lot of patience and can take your time and get a good quality result. So I'll probably only use this a couple times a year. So if it takes an hour to turn down a quality taper and a crankshaft, that's fine. And it seems to do a good job. This is the cylinder head for the AH-82, custom made. I just finished lapping this surface into the cylinder, which I cut the top off. It was a fixed head cylinder. You can see the lapping kind of burnishing there. You can see I relieved this head so just a small band would be compressed against the cylinder to form a seal. And after I lapped it, I went back in the lathe and relieved this about 5 thousandths, just so the contact band for the cylinder head would be raised up, and if the cylinder head went on just slightly off center, it wouldn't hang up on a raised edge over outside of that sealing band area. So like we're right on top, you can see this protrudes on the head here, and that's because on these cylinder heads you can't cut them off down deep, down where the piston pops up to. If you go down deep, then there isn't enough meat in the casting to drill and tap for these holes. So that leaves you having to cut off the top very high and having to make a head with a protruding nose on it that goes down inside the cylinder a good 3/8 of an inch. And I did spend some time fitting this up and going back and machining off the sealing surface to the right height so I could get the right squish distance in there. I set this engine up, it's going to be set at 47 thousandths initially, and we'll see how that works. Okay, here I have the bottom of the AH-82, and I've got the piston on here now, wrist pin in place, C-clip inserted, fitted the rings on here, checked those in the cylinder bore to make sure there weren't any light gaps once the ring was inserted in the bore, and so I know how to get a good seal on these rings. And you can see the holes here that were machined in for the boost ports, and the enlargement of the transfer feed holes in the side of the piston, one on each side. So now you got to drop the cylinder on and get the rings to pop in there. I'll bolt this down and get the head on, and we'll be getting much closer to having this engine set up to run. Yesterday made some more parts. I made this starter pulley here. It's fully machined out of a piece of 3-inch diameter aluminum rod, 6061. I previously turned this flywheel down, reducing the diameter of that. Now this starter cup, I added a couple of pins on the back of that so it wouldn't spin loose on the crankshaft. So you can see on the back side here I've got two roll pins I've inserted there, and the idea there is to have those go into these existing casting holes. I'm not sure what the heck they're really for, but it might be an option for a recoil starter assembly attachment or something. And I just thought I'd make use of those and put some pins in there. This has a little bit of clearance to it, but at least it won't spin around more than a few degrees if the nut comes loose. Now under that nut I'll put a nice spring lock washer, and that'll keep this from coming loose. The problem is when you start this engine, it has to rotate in this direction, which will tend to loosen the nut and spin the cup off. So that's why I added those pins in there. You can see the starter cup I made. Quite a bit of machining on that. Hogged this all out. It's fairly lightweight. It's cupped out. The wall thickness is about a 1/4 inch throughout. At the back side here, where it's bolting down, it's about 350 thousandths thick, a little bit beefier there. But it's very much the same diameter and profile and length as a gem cast starter cup. This is the cylinder head I made. It was in some of the previous videos. There's a spherical chamber. Fits on top of the cylinder that was machined, ported extensively. Got some boost ports in the back there, you can see, and the intake ports were all cut and flowed. Exhaust ports were squared out, raised up considerably, and the fixed head was cut off, and I cut in 8 1024 screw holes for the head to bolt down in. Okay, so in addition to this, there'll be a girdle assembly that will cross the top of the cylinder head. And this whole thing will go together and look kind of like that when I'm done, right? And the girdle will be on top. Actually, this head rotates like that. Since it's a fan-cooled engine, it has to align with the airflow of the fan. And the girdle will cross the top of that head and extend down to the carburetor manifold intake. So I'll be working on that next. Okay, this is the head stiffener plate that's going to be part of the girdle assembly. I'm just putting a large clearance hole in here for the spark plug capacitor. I already put a hole at each end for the girdle tie rods that hold the whole assembly together on the engine. So the idea here is this hole is to run a really large drill bit through here at a slow speed. This is a 1-inch bit. I'm going to take this hole out to 1 1/8 inch to give clearance for the spark plug socket. This happens to be the largest drill bit I have. After this, I'll put a boring head in here and take it out the last small amount. That's a lot of aluminum junk on it. Yeah, that's it. Through. Okay, get the cylinder head on, bolted on the nuts down here, base the cylinder, and put a little oil on there to help this thing seal for pressure testing, and top of the cylinder. And I got this lap, it'll be a lap seal over the cylinder head. So just drop the cylinder head on there. It's a little bit of a tight fit, so that keeps it on position. Just rotate that oil in a couple of turns and bolt this thing down. You've got some extra thick washers here. These are 3/8 OD 60 thousandths thick stainless steel washers, high strength. One of those go under each one of these 8 screws for the cylinder head. So 24 screws. It's about as big a screw as you can fit into the material that's available to work with. Just isn't a lot there. In fact, half the screw breaks out down below between the cylinder fins. But it's just the way it is. Not much you can do about that. But that's the reason we have the girdle system on here. To keep this together, that's what these are here. There's a piece that straps across the top that'll hold the cylinder down and also keep the jug from cracking or breaking off the crankcase down here. So these engines were never really meant to put out a lot of power, so you take some extra measures here to keep it all together. So I'm going to use two hands, finish putting this together, and get back to the video. I'm setting up the timing here, checking exhaust intake degrees, setting the spacing for the cylinder, base gasket adjustment in terms of thickness to move the cylinder up and down. Get a CC of the new head here. It's running a little large. I got to machine a little bit more off of it to get the CCs down to the right level. I'm making a chain guard here for the AH-82. A little bit more work to do on this. Now what I've done here is I've taken a piece of large aluminum tubing, 5-inch OD, 4.5-inch ID, and simply cut a piece that's a little over 3 inches wide and turn a plate that I fit inside the end here. This is a 1/2-inch aluminum plate, and it was turned to just snug fit in, and then I've gone around here and put some 24 countersink screws around this, 8 screws evenly spaced. The next thing I'll do here is turn this into 2 chain guards. You can see the black line there. I'm going to just simply cut the part in half right there now as the next step in making this. And then I'll have 2 chain guards. The mounting holes will go here in the plate. Those will be matched to the motor mounting plate as the step following splitting it apart. Okay, here we go. So I took that part I had assembled and split it on the circular saw. I use a circular saw a lot with a carbide blade, cheap carbide blade, and it makes a real mess cutting through aluminum with it, but it's really fast. So I just split this in half. Now I have 2 chain guards. So I have to finish cut this on the milling machine, get this to the right size and angle. I have the chain guard mounted now. I cut that in half and then just belt sanded the bottom of the surface off since it really can't be seen. Didn't spend a lot of time trying to machine that. Drill a few through holes that lined up in the engine mounting holes, and it's just going to bolt on behind the clutch like that. Polish it up next, give it a nice look. It'll look nice. The clutch on there is a max torque. Had that specially made by Jim Donovan at Max Torque for this engine. It's a custom build. See there, it's an adjustable clutch with a dragon skin shoe material. It's fully adjustable with different springs. I'm going to start out with this at about 4,500 RPM engagement RPM. They have different springs that can allow this to go up. over 7,000 RPM, but that would be way above what this engine would use. So it's probably going to end up around 4,500 to 5,500 RPM when I get it tuned in. So we'll start with the 4,500 setting and an 11-tooth drum. So these engines tend to put out a lot of torque at low RPM, so I'm not going to try to twist this really high like a modern kart engine. It's going to be a really low RPM engine. Probably won't even top 7,000 or 8,000 RPM. Probably 8,000. We got the main engine on the mount now. Bolted this down with actually 5/16 Allen head screws with lock washers and Loctite on all of those. So there were 2 extra holes here that aren't normally drilled and tapped on the AH-82, but there's bosses on the crankcase that I drilled and tapped for that. So got that held very well there, and then I've got the chain guard that was made out of a piece of aluminum tube, 5-inch OD, 4.5 ID, and that's just screwed onto a plate and makes a nice chain guard. So next thing I did was tighten the motor down on these bolts here, so it's held at this end too on the carburetor mounting end. So there's 4, 10, 24 screws in there, torqued and Loctited. I need to make some studs here that'll hold on the manifold and the carburetors. There'll be 2 carburetors or pyramid reed valves. I've got the turn down flywheel, custom made pulley. It has pins to keep it from rotating because this nut is a right-hand thread, and the starting torque will tend to want to loosen this. So I've got pins that go into the flywheel to keep that locked in place. I've got the head mounted here. Everything's torqued down to spec. Cylinders mounted. These tie bars haven't been used yet. I've got the plate that'll go on the end here. That'll be one of the things I'll probably do last, is torque that into place in case I have to take something apart before that. So next thing I think I'd be doing is mounting the clutch and getting a carburetor manifold on here, and then need to get into the electronic ignition. For that I've got a ignition module that I'm looking to utilize there, and this is a Megafire type ignition module, and I've got a place to mount that underneath the engine, and we'll see how that works out. Check the timing of the timing light and see where that ends up. This is the ignition system on the AH-82. You can see I removed the points and the condenser. So just the coils mounted on the old condenser point housing. Put on a new ignition wire and boot. Down here you can see the ignition module. Lighting's not great. You can see it's a Megafire type unit. This one's actually an Oregon brand one. Seems to work the same. Still need to do some track testing on it, but it's just wired in, kind of hidden down there, but out in the open so it can stay cool. And that simplifies the ignition setup. You do have to check the timing with the timing light, as opposed to using a degree wheel to time the points and that type of setup. But I'm going to try this out and see how it works. On this side you can see the linkage on the dual McCulloch flat back carburetors. That's a bicycle spoke formed and bent. That's what they used to use back in the day, years ago. These actually work very good because most of them are a very high tensile steel, kind of like a spring steel. So you can bend them and they won't easily distort. You can put a little bit of bow in it like I did here on this one between the 2 carbs, and it'll act as a spring. And if if one carb bonds before the others, it'll kind of straighten that spoke out a little bit instead of torquing hard on the carburetor. And it also allows me to do some adjustment between the two carbs to synchronize it, the amount of bow I put in there. So the other pull rod here that's loose right now, this will go to the Kart chassis, hook up to the regular throttle linkage hookup, and it'll pull downward in that fashion. The Power Products engine, AH-82. Almost done assembling this. I'm putting on twin McCulloch small flatback carbs for the Zusa velocity stacks. Got the max torque clutch on here. Everything's been torqued and assembled. Got an exhaust header on, open header, no muffler. The girdle tie down. It's all torqued in place. New ignition wire on the coil. New spark plug. Custom made billet spherical combustion chamber head. Reconditioned air shroud from an original motor. I had to relieve the air shroud to clear the head I added on the engine that wasn't originally there. And that's a custom pulley for starting the motor. It's not obvious, but the flywheel that's in here isn't the original AH-82. It's actually off a different Power Products motor. It uses the same coil assembly, but it's a much lighter flywheel. It's a smaller, lighter flywheel. And I swapped that out to make the motor spin up faster and have less inertial mass and less fin area. So the fins are smaller. I machined these fins down to cut down the amount of air they're scooping. The Kart motors run at a high RPM versus something like an industrial application. So you don't need all that fin area, it just robs power. So on a modified motor, it's not unusual to cut back the fins to reduce the air pumping and put the horsepower back onto the rear tires instead. I ran dual range of power last year. It's like we had a hoop out there.
Yeah.
Going around up and down the hills. And,
Yeah, it's fun. Smooth.
yeah.